Okay, this lesson is called the unit circle, which is a huge deal in pre-cal and in calculus. And so our learning target is I can write the unit circle because it's this huge circle that has a lot of implications in math. Whether or not you ever go into a career that uses it, just know that it's a big deal in the math field. And I want you to understand where it comes from and how to use it. And there's just a pattern to it, and it's kind of nice. Okay, so we're going to look at trig functions for any angle first. So if you look at the left picture, okay, so this point right here, that's just an XY point. We're going to talk about some other things. So an angle is always going to start on the positive x-axis, and then it'll end somewhere. It doesn't have to end over there, it'll just end somewhere. So whenever you look at an angle, you look at it counterclockwise. And they're going to use this symbol. Remember, that is called theta for any time you're talking about an angle. And then if you'll notice, what they're doing is they're actually going to make right triangles out of these angles. So the unit circle, it's a circle. It's measured in degrees and radians, but there's also these built-in right triangles, which we're going to use. So Pythagorean theorem is going to come back into play. Just trig ratios that you learned in Math 2 are going to come back into play. All that stuff. All right. So let's do this first one. So let theta be an angle in standard form and a point, xy, be a point on the terminal side of theta. So terminal means where it ends. The distance from P to the origin, r, can be found using the Pythagorean theorem, which if you'll remember, it's usually a squared plus b squared equals c squared, but because we're using xy coordinates, ours is going to be x squared plus y squared equals r squared, because we're talking about the radius of a circle. So that didn't make any sense. So to find this distance, you're actually making a right triangle, but you're using this point. Okay, so when you talk about x, you're talking about like your distance, your horizontal distance. And then when you're talking about y over here, you're talking about your vertical distance. So it's still just like Pythagorean theorem that you've always used, except now you're thinking of it also making a circle. So it's a little weird to get used to. Okay, so let me tell you some ratios that you need to know. Okay, so whenever you find the sine of theta, that should be a theta right there, I'm not sure why it's not, that's going to equal y divided by r. And if you'll notice, so if this is theta, you're still doing opposite over hypotenuse like you always have. You're just not using opposite hypotenuse, you're going to use y over r. So when you do cosine theta, that's going to be x divided by r. So that's your horizontal distance divided by your radius. And tan theta is going to be y divided by x. So that's your vertical distance divided by horizontal distance. So that's just something to keep in mind. These are your little ratios. It's just a different way of looking at them. Okay, so we talk about, so an angle is always going to start here on the positive x-axis. That's your beginning side. And then your terminal side could be over here, it could be here, it could be here. So terminal is just where it ends. Alright, so if you read this, depending on the location of the terminal side of the angle, trig functions can be positive or negative. So using our knowledge of trig function values, we're going to identify functions that are positive in each quadrant. So here's a little statement that you can remember. All students take calculus. When I was in high school, I was taught Appalachian State Teachers College. That's another one if you ever hear it. It's just a mnemonic device to help you remember where they're positive in the quadrant. So let's go over the quadrants. So if you remember, this is quadrant 1, this is quadrant 2, this one is quadrant 3, and this one is quadrant 4. Okay, so if I have an angle and my terminal side is in quadrant 1, all of them are going to be positive. So if the terminal side is in quadrant 1, all your trig functions are going to be positive. If you have an angle and the terminal sign ends up in quadrant 2, your sine function is going to be positive. So cosine of tangent will be negative. If it ends over here in quadrant 3, something like that, then tangent is going to be the only one that's positive. And then if it ends in quadrant 4, your cosine is going to be positive. So if you notice all, meaning that if you're in quadrant 1, all of them are positive. Students, sine is the only one that's positive in quadrant 2. Take, tangent is the only one positive in quadrant 3. Calculus is because cosine is the only one. So all are in quadrant 1. Sine is the only one in quadrant 2. Tangent is the only one in quadrant 3. And cosine is the only one that's positive in quadrant 4. So that's just a little phrase that you can remember and you can check over your work. Okay. Alright, so pay attention to this little picture over here. So here's my beginning angle, and here's my terminal side, and, oh, did not mean to do that, sorry. This would be my angle theta, but this one over here, the one that makes it 180 degrees, kind of completes that, is called my reference angle. So for an angle theta in standard form, the reference angle is the positive acute angle formed by the terminal side and the x-axis. Okay, so the angle in green is like my beginning angle and my terminal side, and that's my theta. The one in red is the one that kind of completes that until it gets all the way back to either 180 or 360, and that's called my reference angle. So if I look at these three pictures on the bottom, so I can kind of estimate 150 degrees. So if it was right here, it would be 90. If it was right here, it would be 180. And so somewhere in between that, let's say about right here. So this would be theta. So my reference angle would be this one right here. And if I do 180 minus 50, I get 30 degrees. So my reference angle is 30 degrees. If I do the next one, I always start here, and then if I had to go to 315, remember this is 90 degrees, this is 90, this is another 90, so about right here. So I'm going to go all the way around. That's how I get 315 degrees. So my reference angle is going to be this one. So if I do 360 minus 315, I get 45. So this angle would be 45. So it's either going to be equal to 180 or equal to 360. Okay, so whenever I do a negative angle, I'm still going to start here, but I'm going to go clockwise position. Alright, so if I go here, it would be 90. Another one would be 180. So somewhere right here, in like this direction, that would be 240. But if I wanted to finish it, I could do like right here. And think about that. That's went 3 quadrants over, so that's 270 minus 240. So that angle right there would be 30 degrees. Okay, so the reference angle is what's going to take the green angle to the next quadrant, if that makes sense. If that doesn't make sense, come ask me and I'll draw you some more pictures. Okay. And then we talked about radian. So radian works the same way. We've already went over how to convert radians to degrees. So if you don't remember that, you can go watch that video. 5 pi over 3 is 300 degrees. 7 pi over 6 is 210. And then negative 5 pi over 4 is negative 225. So what I want you to do is I want you to pause the video and I want you to see if you can draw these angles. I'm going to draw them in green. You can color code it if you want to. I just want you to draw the angles that are given, and then we're going to find the reference angles. So pause the video and try that in 1, 2, 3. Okay, so that should be what it looks like. Now the reference angles are going to take that green angle to the next quadrant. So I want you to see if you can draw it, pause the video and draw the reference angle, and then we're going to figure out what the measure would be. So do that in 1, 2, 3. Okay, so in red are your reference angles. So reference angles are always going to be less than 90 degrees, just hint, hint. So if I look at the first one, that would make a complete circle, and when I subtract it, I get 60. So this angle right here would be 60 degrees. This one, to get to the next one, would be a 270. So 270 minus 210, that gives me 80. So right here would be 80 degrees. And this one, the next closest one is 270. 270 minus 225 is 45 degrees. So this right here would be 45 degrees. And now we're just going to convert it back to radians. All right, so this is actually pi over 3. This next one is pi over 6. Oh my goodness, I just realized that 270 minus 210 is not 80, it's 60. How embarrassing. Okay, and then the last one, 45 degrees, is the same thing as pi over 4. Alright, so let's move on. So here we're going to start to build the unit circle. Alright, so you have this circle. Everybody should see that. But you also have kind of an embedded triangle within the circle. Okay. So a unit circle is a circle with a radius of 1. Anytime we talk about the unit circle, it always has a radius of 1 unit. Because the value of r is 1 for each point on the circle, the trig functions are defined as, don't look at this, I'm going to write it a little clearer. So anytime you talk about sine of theta on the unit circle, it's going to be equal to y. So right here would be y. So that's your horizontal distance. Anytime you talk about cosine of theta, that's going to be equal to x. And that's your, sorry, that one's your horizontal distance. The y is your vertical distance. And then the last one, tan theta, is always going to be equal to y divided by x. So your vertical distance divided by your horizontal distance. Yay, Miss Lake got it right. Woohoo! Okay, so here's your big thing to remember. The coordinates of P can be written as cosine theta, because that's just an x coordinate, sine theta, because that's a y coordinate. Okay, so when we talk about the unit circle, there's 16 points that we'll look at. The unit circle is frequently used to map 30 degrees, 45 degrees, and 60 degrees, and their multiples, as well as 0, which is the same thing as 360. You'll see 90 degrees on there, 180 degrees, and 270 degrees. So these are where you get your 16 points. Okay, so there's a video to watch on how to fill out the unit circle and how it all correlates. And it's a little tricky at first, but then there's a pattern to it, and it's really easy to use. And I would just feel like an awful teacher if you ever got to pre-cal and had never even seen the unit circle. So that's why we're doing this, because it's a big deal in math. Even if you never use it, it is a big deal in math. So I want you to go fill out the unit circle. There should be a blank one attached. You can watch the video on how to fill it out, and then you'll turn in the one you fill out completely. All right, let me know if you have any questions.